Hello, everybody. Thank you so much for joining us today. This is the second in a new series that we started this year, co-created by Women in Automotive Technology, or WAT, and PAVE. My name is Caitlin Magny Miller. I'm PAVE's Communications Director, and I also serve on the board of WAT. I'll be moderating today's panel. And because we're merging two audiences here, I want to give a very brief background on PAVE and WAT for those who are maybe familiar with one and not the other. PAVE is a 501c3 nonprofit that's dedicated to educating the public on autonomous vehicles and their potential. We're a member-based organization. And we also work with the public sector and academia as well. And for those who aren't familiar with WAT, we are a professional membership organization that offers programming to women to connect throughout the industry, foster leadership, create connections, and really deepen industry expertise. So today we are going to be talking about safety in the AV industry and really exploring some of the latest in testing and validation, risk assessment, and building public trust. So I really want to start by introducing our guests today. We have Darcyne Foldenauer of the Autonomous Vehicle Safety Consortium, or AVSC, Tanya Hood from Forterra, and Shobana Sankaran, formerly at Nauto and Avail car sharing. So let's start with some intros. Darcyne, let's start with you. Can you give us a brief background on yourself and your work in the AV safety space?
The Automated Vehicle Safety Consortium, as Caitlin mentioned, and I'm the executive director. I've been involved with SAE in this role for about 3 years. Prior to that, I was in the automotive industry for many years. I hate to say how many, but I was as a director of quality in the automotive manufacturing world. And then prior to that, was also director of program management. Both roles really good fit coming into the AVSC, which really requires a lot of management of projects, as well as being obviously focused on safety. Quality is a big aspect of that. So there you go.
Wonderful. All right, I'll switch over to Tanya.
All right, so I've spent almost the better part of a decade in tech. Prior to tech, I was actually in aviation, so that'll kind of give you the foundation of what I'm doing now. Background in safety management system, and I helped to kind of bring that up at Uber, and then spent some time at Cruise before coming to Forterra. My main focus with safety and AVs has been on safety risk management as a part of safety management system. And thankfully, my time spent here at Forterra, I've gotten to broaden that kind of brushstroke across all of the SMS and really dig into a lot deeper concepts, especially as they tie into safety engineering and systems engineering and how we actually create this like aggregate perspective on safety, considering all those different disciplines.
Wonderful. Shobana.
Excellent. Thank you for having me, Caitlin. Hello, everyone. Greetings from the San Francisco Bay Area. I work at the intersection of risk, safety, and commercialization of emerging mobility models. Most recently, I was the Director of Insurance, Trust, and Safety at Avail Car Sharing, which is a two-sided peer-to-peer car sharing marketplace incubated within Allstate Corporation. I spent the first 12 years or so of my career in the auto insurance industry at Progressive, Esurance, and California Casualty, where I was focused on driving innovative risk assessment methods, including leveraging telematics, driving profitable growth. I then moved to an AI-based startup called Nauto, where I helped to build and scale a computer vision-based driver behavior safety platform for human-driven commercial fleets. I was the first business hire at Nauto, so I helped shape the company's initial product strategy. And then as vice president of global insurance, I executed Nauto's strategic partnerships with the commercial auto insurance industry. That experience really kindled my passion in building and bringing to market safe, efficient, emerging mobility solutions. I am currently exploring my next role in commercializing autonomous transportation with a focus on the right insurance, risk, and safety models to enable scaling autonomy. Looking forward to the discussion.
Wonderful. Thank you all so much. So as you can see, we have a really diverse set of perspectives and expertise here, and I'm looking forward to getting into the discussion. Shobana, I'm going to stick with you, and I want to level set with a really foundational question. Can you talk about why safety is so central to AV development and deployment?
Sure. Safety in AV deployment and development is akin to hygiene at a restaurant, right? It's just table stakes. As autonomy advances, trust and safety are the true benchmarks. Trust, culture of collaboration are exceedingly important and just essentially the entirely human ingredients for AI systems. No amount of technical horsepower can overcome a lack of trust, as we know. So the synergy between, a trust building system, the ability to execute in a very high velocity space that we are in, and a collaborative culture is a profound advantage. So we need to be able to build and deploy robust systems that are just inherently designed to create and sustain trust. Because AV is in a safety critical domain, to recognize that trust and culture are table stake inputs for AI systems, and they're actually harder to replicate than sophisticated machine learning models, and will really give a competitive edge to the organization that's able to execute in this manner. So for example, dedicated teams to proactively and routinely report and review relevant incidents, not just internally, but also with regulators when required, fostering regular ongoing collaboration, creating public trust. How do you prevent a single safety incident from becoming catastrophic? Even if the incident is a technical mistake, how do you ensure public trust is not eroded? If the industry wants to earn public's trust, it will need to be transparent about safety, having a high bar for safety, and clearly defining, how safe is good enough.
Yeah, I think you've made some really important points there, and I love the connection that you made between safety and building public trust. Obviously, that's something we're really focused on at PAVE. And Darcyne, I want to switch gears a bit here. How do you think we should be thinking about safety benchmarks for AVs compared to human drivers? Should they be expected to simply match human performance, or do you think they're expected to exceed it? And if so, by how much?
There's a lot of discussion on that in the industry today. The general consensus is really that AVs should exceed human performance in terms of safety. So human drivers can be very prone to errors, distractions, fatigue, texting, a lot of those leading to accidents. So AVs, on the other hand, they have the potential to operate with a much higher precision and consistency without all those issues that humans bring into the equation. So the goal for AVs is to achieve a level of safety that significantly can reduce the likelihood of accidents compared to human drivers. So, and when you think about it, ultimately, AVs need to be safer than human drivers if they're going to gain public trust and gain widespread adoption. That is definitely needed.
Absolutely agree. I think as humans, we have a hard time wrapping our minds around the fact that sometimes we aren't great drivers. There are a lot of factors involved in that, and I totally agree. Tanya, I want to switch over to you here, given your technical background, and I want to cover sort of the foundations of safety in that sense. What are the key building blocks that make AV systems safe, and how do they work together to really create redundancy and reliability?
Awesome question. So I'm going to take you guys on a micro journey. I'll try to be quick and not nerd out too much into the rabbit hole. But initially, I kind of want you to think about everything that you do day in, day out. You are managing the risk of those things. So whether you're driving a car, whether you're going on a hike, you're managing risk. And what does that mean? And how do you look at risk? So from the SMS perspective and safety risk management in SMS, everything that is around us, we consider a risk control. One large kind of bucket of risk controls is technical, getting to your question, Caitlin. So if you think about the technical aspect of the AV space, you look at different components, you look at different sensors, you look at different subsystems that become a system, that then become a systems of systems. Now you have an autonomous vehicle, in the real world. And what really matters, it's not just what is the risk of an individual system, subsystem, or component. What you want to understand is how is that performance in isolation? And then how is that performance in aggregate? And so I kind of look at it, the building blocks. I'm not going to give you a very specific answer in terms of this sensor must hit this reliability threshold, for example, but really it's how can it fail? How can it succeed? How do you define success? How do you define failure? And when you combine all of that and you get kind of either a numeric or a qualitative estimate of those performances, does it meet the needs of the company when it looks at, is this acceptably safe? And so going back to like your initial question, how does that work together to create redundancy and reliability? Just because you have a failure in one space does not mean that the total system will fail. You also have to look at, if X fails, what do we need in terms of performance of Y and Z to get an aggregate effectiveness rating of that overarching AV risk control when you combine all of its sub-risk controls together into the grander picture?
I think that's a great explanation. And as you've outlined, there are really a lot of layers to that. So absolutely. Shobana, ensuring safety, of course, requires a lot of testing and validation. Can you talk about sort of the various ways that AV companies test their technology today?
Sure. Testing, and I'll build on what Tanya already said. So testing and validation is done pre-deployment, but there's also post-deployment evaluation and really completing that feedback loop to be able to inform future rollouts, right? So we'll assume there's a safety framework across hardware and behavior and operations, and also a safety case, which rigorously tests the theoretical assumptions with the real world performance. Most importantly, which is transparent, defensible, and production ready, right, for real world deployment. So specifically, having operational processes in place for fleet maintenance, for remote assistance operators, for cleaning services, for sensors, all contributing to the safe operations of AVs. And then there's the safety impact data, right? So continuous review of operational data to validate these safety assessments. Here I'll call out that any internal safety assessments should be designed to provide clear evidence in the event of an incident, right? And here also that independent safety assessments and independent validations done by external firms also seem to help build confidence in the technology and lay the foundation for more reliability. Finally, there's the deployment readiness, and Tanya touched on this, but determining whether the AV is ready for deployment in a new area, here with an approach to focus on the absence of unreasonable risk. And there's literature put out by firms in this area specifically. So now moving to post-deployment, how do we demonstrate superior safety impact through data and through empirical evidence? So this is very critical for building confidence with not only passengers, riders, but also with regulators, with insurers, and the other players in the ecosystem. So how can we analyze claims data, right? For example, from millions of autonomous miles driven. And here's where I'll call out, Waymo as an example firm that has demonstrated significantly lower frequency of property damage and liability claims compared to human-driven vehicles. As Darcyne mentioned in her point, right? Including human-driven vehicles that are equipped with ADAS systems. Right? And what is getting more granular, what is the impact on vulnerable road users? What is the reduction in serious injuries compared to human drivers? And it's worth mentioning here that, of course, simulation plays an important, salient role in this type of AV validation. There is literature on this topic, so we won't cover it here in detail, but it is a main tool, right? It is comparing it to real events in AV validation, and it's fairly advanced for both research applications and real world applications. The punchline is that the onus is on the organizations to define what is safe enough, demonstrate that it's met, navigate regulatory landscapes, and accelerate time to market, all without compromising safety.
Absolutely. Totally agree and appreciate your points on both, pre-deployment testing and validation, but also post-deployment. That's, of course, a really important factor as well. Tanya, coming back to you, you are a longtime member of the AV Safety InfoShare, which convenes safety experts from across the industry. And this was largely built on the success of the aviation industry's InfoShare model. What do you think the AV sector can learn from other safety critical industries like aviation?
I think there are two key points I really want to kind of hammer out here. The first is sharing of information. There's no competition with regard to safety. And I know that's a very provocative statement, but in aviation, they have InfoShare. They have a lot of different forums actually where you have experts across multiple disciplines in aerospace or aviation, pick your companies, whether that be design, manufacturing, operations, that get together on a certain, frequency, and they discuss what are common issues you're seeing, how did you solve them, what's the latest regulation, how are you complying with them, what could be made better, what are the gaps that you're identifying with regard to your tech, with regard to location, with regard to ops. I won't keep going down the litany of items that you could consider, but I think the first point really is there is no competition when it comes to safety, because the intent of safety is to preserve, for example, human life or to preserve resources. And so how do you compete when your end goal is the same? Your objective is, preserve human life and preserve resources. The second item, and I'm going to take example, not go into it in deep detail, but with Boeing aircraft, and we had the MAX, and we had all of those issues that happened. Without going into the full-blown report that was provided by the NTSB of what was actually going wrong, there were assumptions that were being made, there were decisions that were being made, there were opportunities for improvement that were existing when it came to culture, when it came to policy, when it came to regulation, when it came to conversation with each other, when it came to you modified the system in a way that you assumed would not have an impact on the operator and how they function with that system. And in reality, there were deep impacts across multiple operators with regard to how they changed the MAX. And so the second point I would want to say is never assume that your assumption is correct, and never assume even a tiny change you make won't have deep and big impact on the systems that you're trying to create and deploy into the real world.
Great points. Having, going back to your first point, having attended the InfoShare, it is so cool to see, leading companies in this industry really living up to that phrase that we're not competing on safety. It's really fantastic to see that in the industry. Switching gears a bit here, Darcyne, the AVSC works to create best practices that really inform and lead to industry-wide safety standards. Can you talk about the current safety standards and certifications for AVs? Where do things stand today, and what more is needed, do you think, to ensure really consistency across the industry?
Yeah, actually, I do want to also follow up to what you had just mentioned with Tanya, and just the fact that we're not competing on safety. I think the AVSC is a prime example of that. We're a consortium made up of 7 different member organizations, and they all come together under an umbrella strictly to do that. They set aside all their competitive differences, and it's amazing to see these companies do that, where they want to come together and not compete on safety. So just wanted to say that. To frame up and answer your question about safety standards and where we're at today, currently safety standards for AVs do include various guidelines. We have them, of course, from SAE, which is my organization. ISO examples come from NHTSA. But just to give you a few, we have SAE J3016, probably one of the most well-known standards because it defines the levels of driving automation, from level 0 to 5. And it also prescribes a common language, just for describing the capabilities of AV systems. You have others like J3018. That is a standard that's focused on safe testing of AVs on public roads and provides guidelines for conducting these tests in a safe and controlled manner. Similar to what Shobana was saying, right? How are these companies testing and validating? That is a standard that is very well known and followed. We have J3061, another one, just a standard that offers a framework for cybersecurity in automotive systems and ensures that AVs are protected against cyber threats. So when you think about that, we have quite a few guidelines out there. Development and refinement of these standards does continue, and it's trying to keep pace with these advancements that we have in the AV technology. There's still a need for more comprehensive and universally accepted standards to ensure consistency across this industry. The AVSC, as an example, we're getting ready right now, pondering 18 different topics for our next best practice. So if that tells you and shows, there is no lack of topics for this industry. And all of those 18 would be addressing gaps that we see currently existing in our industry standards and guidelines.
Yeah, sounds like there's a lot of room for growth in that space. I want to talk more about sort of insurance and liability here because they are such key pieces to the safety ecosystem. And Shobana, given your expertise in this space, how do you see these frameworks sort of evolving to keep pace with AVs?
Yeah, great question, Caitlin. And let's talk about insurance from two use cases. Okay, one is risk assessment, and two is from a claims perspective after the fact, right? On the risk assessment piece, traditional insurance models are based on, as we know, human driver behavior, specifically placing liability on the driver for their negligence, such as being distracted while driving or speeding. AVs and specifically higher levels of autonomy, L4 and L5, require new approaches to evaluate risk, right? Focusing on system reliability, software integrity, the technology itself, right? The responsibility for the collision shifts to the AV technology itself. So therefore, the field of liability has to expand, right, to include all of the different AV stakeholders. So insurance frameworks do shift from driver negligence to product liability based on this transfer of control from the human to the vehicle's automated systems, and whether the product, in this case, the vehicle and the software, was defective or unreasonably safe, right? So I'll just mention one insurance speak. So in insurance speak, we're talking about a commercial auto policy for the operation of the AV, an excess liability policy for additional layers of protection, for large losses, for example, and finally a technology, errors and omissions policy, which is vital for covering potential failures related to software, AI, sensor technology that addresses the product liability component of AVs. Now, the key is that these frameworks do need to be able to scale, right, as the technology scales and expands to new operational areas. And that's the work that the industry is doing. For completeness in this conversation of liability, I'll just mention that there is the notion of shared liability, right, in semi-autonomous or L2 and L3 systems that do require human supervision if the driver, it fails to take control back. And this is more complex because it then would need to involve determining what is the root cause of the collision. And so the insurance then would need to assess the level of risk for each mode of human versus when the automated features are engaged, right? The second use case, which is beyond risk assessment to claims, becomes much more data driven, right, from the traditional sense. So when a crash does happen, when a collision does happen, the black box, of an autonomous vehicle will become critical for determining fault. So unlike traditional collisions where, evidence might rely on skid marks or witness statements, etc., AV claims adjudication is going to heavily rely on digital data logs, right? These logs capture sensor data, they capture software updates, the vehicle's decision-making process, and they provide a detailed moment-by-moment account of the crash. So going back to our discussion initially on internal safety assessments, these are designed to provide clear evidence in the event of an incident, right? And finally, I'll say that best practice is to really approach insurance by proactively demonstrating the inherent safety of the AV technology through rigorous data analysis, transparent safety practices, while also securing a comprehensive insurance coverage that addresses the unique risks of autonomous systems.
Excellent answer. And I think this is certainly a topic we could spend much more time on, but given our constraints, yeah, great summary. I want to talk a little bit bigger picture here, and I'm going to switch over to you, Darcyne. At PAVE, we address a lot of skepticism and misconceptions around safety in AVs. How do you think the industry can really effectively communicate safety practices to the public?
Well, there are several opportunities that come to my mind, but in light of the time, I'm going to pare it down to just a few. I think the first one is just transparency and education. Educational campaigns can really help demystify AV technology and address some of these common misconceptions. As an example, the AVSC, we participate in events. The next one coming up for us is Move America on September 25th, and that's at Huntington Place in Detroit. We'll be talking about immediate post-crash behaviors and talking about misconceptions. We're going to be addressing that topic. Beyond AVSC, and based on my own experience in the automotive industry, providing clear and accessible information about how AVs work, the safety measures that are in place, and testing results would go a long way in public trust. So transparency and education. I think number 2 would be engaging communities, engaging with them. You know, a lot of our AVSC members go out and they do, some of them refer to them as a road show, but they take some of their AVs and they are actually working with all the first responders. They can do that through town hall meetings, interactive events, many different ways for them to interact with the first responders. So this engagement really allows the public to ask questions. They can voice their concerns. They can see the safety features in action. And it's all something that I have seen from our AVSC members, as I mentioned. So the third thing would be addressing public concerns. I think actively listening to public concerns and addressing them through targeted communication is crucial. This can include providing detailed responses to common questions, actually addressing some of these myths and misconceptions that they see, and highlighting the benefits of AV technology in terms of safety and efficiency. I think it would go a long way.
Yeah, absolutely agree. Certainly, I always say at PAVE, education is a two-way conversation. And I think you hit the nail on the head. We really have to listen to people's concerns and questions in order to really effectively communicate to them. Tanya, Forterra works in autonomy beyond just the AV space. How do safety requirements differ across applications like defense or other ground systems, for example? And what lessons do you think can kind of carry over to the AV world?
Yes, so I'll keep this short, also knowing that we are pretty close to time, but in a nutshell, if you look at different requirements, different standards, different regulation across either the commercial space or where we are, which is also the defense space, taking it back to safety specifically, you have MIL standard 882E, which is something that we comply with for our defense technology. And then on the commercial space, you could subscribe to 26262, certain fault management, and SOTIF. I'm not going to keep going because I'm sure everybody's heard of all these different standards, regulations, and best practices. But what I want to get to the bottom of is, if the intent is that the technology, understand the technology, what are the hazards, what are the risks, what are you doing to mitigate those and get you to an acceptably safe state to support a safety case, for example, which was brought up earlier. If the intent is there, we've actually found out that we can borrow a lot of the content, a lot of the information, a lot of the practices from our defense side and apply it to the commercial side. It doesn't matter, and I don't mean to be provocative, it doesn't matter what label you slap onto it of like what the standard is or what the best practices or regulation. It's, are you actually achieving the mission of effectively managing the safety risk associated with your technology? And that would be, to answer your questions, like what lessons carry over to AV if we look at the defense side versus the commercial side, is the lesson is effectively manage your technology safety risk and ensure that everybody who's operating in and around that technology understand the risk associated with it. And that's where I'll stop, just again, due to time.
Appreciate that. Very concise, but also completely agree. It's very cool to see how a lot of these big picture lessons can carry over. And bearing in mind that we do only have a couple of minutes left, I have sort of a final question for everybody. Looking ahead, what do you all see as sort of the biggest opportunity or maybe the biggest challenge for advancing AV safety in the next few years? Darcyne, did you want to start?
I think as we see more AVs on the road, this also means that there's going to be more data being collected and established that can be used for continuous improvement and lead to safer and more reliable AVs. So I see this as a huge opportunity for accelerating public acceptance of the industry. On the flip side, the biggest challenge, I think, is going to be gaining public trust and acceptance of these vehicles. You know, despite advancements in technology, there's still a lot of skepticism and concern among the public regarding the safety of these vehicles. So as mentioned earlier, addressing these concerns with transparent communication and education and sharing of validation testing and establishment of comprehensive safety standards, I think, is still needed.
Great. Tanya, I'll pass it to you.
Yes, so I will say I'm looking at a coin, one side's opportunity and one side's a challenge. And I'm just going to say regulation. And we all know the intent of regulation is to improve the safety of outcomes associated with the industry that it's trying to regulate or govern. And I will say, after sitting in so many different forums and consortiums and trying to say, what is the best practice? What is the standard? I'm going to selfishly speak to SMS for just a brief second and saying, you could borrow from the FAA for aviation, you could borrow from ICAO, which is international in Europe, you can borrow from IATA, which is global. These are all different standards associated with how to implement an SMS. We don't have an actual regulation for SMS in this space. We do have best practices and standards, but everybody's doing something a little bit different. And I think the biggest opportunity is if we all agree to certain principles, and if we could get regulation out, we could actually hold ourselves accountable to that, especially with federal oversight. And the reason why I say like opportunity and challenge, the opportunity is if we're all doing something similar, we have a bar. The challenge is get everybody to agree on the same bar and have it still meet the intent of improving safety. That's going to take us an interesting place if we can actually get something on the book. And I completely agree with you, Darcyne. And I'm so glad to work with AVSC on these items. Thanks.
Well said. All right, Shobana, take us home.
Okay. Well, I'll come at it from a business perspective, right? So we have to continue to build the ability to manage, measure, and mitigate risk, ensuring that the next wave of autonomy is safe. We have to build scalable business models with deep partnerships across the transportation industry, which prioritizes trust, puts people first, right? We've said those things, and I want to reiterate that. The biggest challenge is not collaborating effectively, right, across the constituents in the ecosystem. We do need a shared commitment to advance the deployment of autonomous vehicles, to make them smarter and more reliable. And, we have companies already who've done a great job of getting the service up and running, the technology up and running, the operations up and running, all with an abundance of caution, high bar for safety, but we have to now make it commercially scale without compromising safety or without compromising the quality of the experience while creating market value. Thank you, Caitlin.
Absolutely. Well, our time is up, everybody. We could obviously go on for another 30 minutes, but thank you so much, Darcyne, Shobana, and Tanya, for your time and your insights today. And thank you to all who joined us. We will be posting the full video on PAVE's YouTube channel later today if you want to share it with a friend or rewatch anything. But we appreciate everybody's participation. Thanks so much.
Thank you.
Thank you.